In this first one, we have a quadratic graph. So we're going to take the parent function f of x is x squared and then flip it to our function notation to see what's going on. So we've got f of x plus 1, that's x plus 1 squared, with a minus 2 in front and a 4, a plus 4. So what we're going to do is we're going to move our parent graph left 1. We're going to make it tighter, so that's a stretch. And we're going to flip it as well. It's going to be upside down, and we're also going to go up 4. Okay, so let's take the parent graph and do those different things. So we're going left and up and then flipping over. Our y coordinate is what happens when x is 0. So I'm going to go back to the equation and put in x is 0. So that would give me y equals 4 minus 2 lots of 1 squared, which is 4 minus 2, which is 2. So now I've got enough information to draw. So left 1 up 4 gives me a vertex in this quadrant here. And then this point here would be minus 1, 4. And the intercept is 2. And now I just need the roots. So to get the roots, I'm going to put in y is 0 and solve, y is 0 and solve the equation for x. So that's going to give me 0 equals 4 minus 2 x plus 1 squared. So I'll move the thing to the other side. X plus 1 squared is 2. So x is minus 1 plus or minus root 2. So this point here is 1 minus 1 plus root 2. And this point here is minus 1 minus root 2. And in between the two is minus 1. Next, we have parent function f of x equals 1 over x, we can see here. And if we flip this notation, we get y equals 4 plus 1. It's f of 6x. f of 6x. So this is going to move the graph up 4, and the 6x is going to stretch it scale factor of 6 because it's inside, so it does the opposite, so it's going to kind of squash it in. So let's have a go at drawing that. Our vertical asymptote will still be on the y-axis, and that has equation x is 0. Our horizontal asymptote has gone up 4, so it's now at y is 4. We don't have anything flipped over, so it will be up here and down here. And all I need to do to finish it is find the x-intercept. The x-intercept is where y is 0, so I go back to the equation, replace the y with 0 and solve. 4 plus 1 over 6x is 0, is going to give me, we'll go down here, 4 equals minus 1 over 6x. Reciprocate both sides and move the minus, and then divide both sides by 6. X equals minus 1 over 24. Done. The next two are not transform parent functions. They are factorised polynomials, so these are actually much easier to sketch. So we need the roots, 3 over 2 minus a half twice. We've got 0, got a half, we've got 3, and we have minus 1. So we've got a quartic for this second one. It's got 4 x's, and 1, 2, 3, a cubic for the first one. The first one is a positive cubic, because if I multiplied the 2x by 2x by 2x, then I'm going to get positive x cubed. And the quartic, well, I've got positive, negative, negative, positive. So if I expand all that out, it will be positive overall. So now I just need to join the dots. So we have minus a half, and that's a double root, so it's just going to touch the axis there, and 3 over 2, which is a single root, so the cubic is going to slice through. So it comes up from minus infinity, touches at the double root, and then goes off straight through the single root. I need to work out the y-intercept, but that's pretty easy. I'm just going to go back to my equation and put in x is 0. So I'll get y equals, where can I squash this? 5 times minus 3 times 1 squared, which is minus 15, which goes there. Last one, I'm going to join the dots again. So the dots this time are at 0 and a half, and 3, and minus 1. and this is a quartic, so it's going to come down, no double roots here, so it's going to come down and slice through -1 and then up and then down and then up again, something like that, and it goes through the origin. So we're done.